Welcome everybody to the Las Vegas Python user group. I'm Adam Englander, I'm one of the organizers. And today we're going to be having a presentation which I did a little last minute. Last month we couldn't come up with a topic, so I said dealer's choice and then lost track of time. But today we're talking about building a simple agentic app. So this should be easy enough to follow along if you're not a Python expert. It should be easy enough to follow along if you're not an AI expert. But really the only prerequisite is Python. What we're going to go through is it's a simple app built in a command line app. Right, so you don't have to worry about it being a web app or all that kind of extra stuff added onto it. It'll trace all the events to show you what's going on. It'll finish with a bounded behavior and offline proof. So it doesn't connect into anything, right? It's all static data. I haven't actually pushed the final version up to GitHub yet, but if you pull it down, you should be able to run it. It'll just require specifying what model and an API key for either Google or Anthropic or OpenAI. But this is not a good at showing you how to write a production application. The framework that we're using is Light LLM. I don't think I would use it. The reason that I used it is it was very lightweight, and it didn't create a lot of abstraction. So I would likely, at my work, we use, of course I'm going to forget the name of it, a much more complicated library that abstracts a lot of this work you're going to see because it just kind of manages it so that you don't have to write it, which is preferable to us. And also, we're advanced enough that we can, when the library doesn't work, we can dig into the inner workings of the library and figure out what's going on. If you're not advanced, these nice frameworks, these LLM frameworks are great when they work. When they don't work, it's very difficult to figure out why they don't work. So if you're just getting started, something simple like this might be better. So basically this is a really, really bad help desk agent. It only does a few things. It only knows about a little bit of data. But what you're going to do is you're going to possibly create a ticket, right? You're going to pass it a model, and that model is just the notation that is accepted by Light LLM. And so it will start up so you can use whatever model that you want. If you wanted to test this out, you might be able to get away with it on the free Claude AI. If you run it on a if you run on an older model, which should still work, it will be very inexpensive if you just want to play around with it, right? Give them $10 and you can mess around with it probably for a day or two. And it does one valid run. It keeps the history so you can talk about things. So it's just kind of an example of how things work. Sorry. The most important thing I forgot to say is that we never give the agent code, right? This is the idea behind agentic applications is that the model determines what it's going to do. You tell it what it has available to it, and then it figures out where to go from there. So in this example here, right, the model, you're going to ask the model, right, to do a customer lookup, right? You give it a customer ID, which is customer 01. Right, and it's this is what's going to show on the screen. It just kind of goes through there and it finds the customer for you because that one exists. And then it will be able to give you information about that. It'll check up on services. So you asked it something about authentication, checks to make sure, yep, the authentication service is operating normally, right, because it has access to that tool. So the AI, right? So these are the steps that it's following. It's like, oh, yep, I've got this customer. Great, they're an active customer. I go look, they're trying to authenticate. I go look at the authentication service. It's running normally. So it's not a system-wide problem. So it's probably something with the customer account. And again, this is basically just a loop that that you're having where you're giving the model information. Here's what you have. It says, go do this thing. And you go do the thing and give it the response. And you just keep on that loop. It just keeps saying, okay, well, now give me this thing. And you do that and you give it the response. Right? We've had a few discussions, although I see a lot of new faces. We've had a few discussions on agentic stuff, which is like, this is basically what you do, is you provide a tool set to an LLM in your application, and you tell the application, or you tell the LLM, here's what's available for you to use, and it will tell you what it wants to use. Oh, and by the way, if you have any questions while I'm doing this, please ask while we're talking about it. If it's going to be explained later, I'll just tell you it's going to be explained later. But I would rather do it in context rather than waiting to the end where you may or may not remember the question and I may or may not remember what you were talking about. I don't mind being interrupted at all. So the answer synthesizes the observations, right? So the final answer is based on all the observations that it did with the tools that it had available. Against the evidence supports every customer-facing claim, and Python validates the required response structure. This is actually like I've been interacting with models for a long time. I've been interacting with models for a long time in the real world, right? Like 3 years is a long time. And this is actually something that I hadn't thought of, right? One of the reasons I like to give presentations, even about stuff that is at a much lower level than I'm used to doing, right? Much less advanced, is because sometimes the simple things are super important. Like when you get an error, when you're trying to process the response from the AI and it gave you an invalid error. I actually have this problem in one of the applications that I run. Pass it through a validator, and validator says, right, it's supposed to score something 1 to 5, and it returns a 0. Well, that's not 1 to 5, and the system doesn't know how to deal with 0, so it errors and just continues on. But what it should do is it should actually tell the AI, hey, your answer is not valid. Give me a valid answer. And that actually works. I have seen it happen once in testing out the application, although it's doesn't happen very often. And that will depend on what model you're using as to how likely it is to give you the proper answers when you give it a schema. So again, correct outputs or outcomes depend on the evidence. If it doesn't have evidence, it can't actually figure things out. So if you try and use this thing and play with it, it could have, if you ask it about things it doesn't know about, it doesn't have a whole lot of understanding, right? One of the first things I found is when I had AI generate the app and the presentation. The examples in the presentation, the examples in the README didn't work because it didn't use valid customer numbers that it knows about because it's a static amount of data. So it was not working very well. And then once I told it to, hey, update your README so if people actually follow along, it'll work. It worked a lot better. Different circuits produce different tool trajectories, right? So depending on what you're talking about, it is a different flow, right? So if you've ever has anyone here written a decisioning system? Yeah. That's a lot of awful logic, right? You might create a state engine, you might create a rules engine, right? But there's all of this like if then else, right? Or switch statements with 50 different items. That may be static, it might be generic. Making it generic is even harder if it's configuration based. The beauty of AI-based agentic applications is that you don't have to tell it what to do. You tell it what the rules are, and it figures it out. How well you explain the rules and how good the model is depends on how successful it is. And in most cases, when you're doing agentic applications, one of the tools it needs to have is how to communicate with the user. Because if it doesn't know, and it has no way to get more information, it will just make one up a lot of the times. It's getting easier, but it is still fairly difficult to tell a model, when you don't know, just say, I don't know, and that is your answer. It will, based on certain information, it will make assumptions. Sometimes that's fine. The work I do, that is not fine. It has to be accurate, it has to be correct, and sometimes people will give it bad information. I work on an insurance application, and when someone says, hi, I want to deny, there's no coverage for this item, so I'm denying, there's no coverage for your pool enclosure because we don't cover unattached fences. But you may have something in your policy that actually says that it does, right? There are pieces, it can come together through that policy, and it can make up a reason, right? It can be like a really, really sleazy salesperson and piece together sentences, or a really crazy news channel. It can piece together sentences to make it sound like it's not covered, right? It's absolutely covered, but it's like, I have to come up with an answer, so I'll do it. So you want to make sure that you give it the option and test that option, that it can prompt the user for more information when it needs clarification, right? So in our application, it just says, I couldn't find any policy citation for that. And that was an immense amount of work to get that to actually happen, as opposed to just making up stuff that is right out of your homeowner's policy. But piecing the words together doesn't mean that it's actually valid. And in the application here, right, the trace exposes the decisions and evidence. So you wouldn't do this on most applications. You might see this if you use, Cursor or Codex or Claude code. You might see it's giving you evidence as it goes along. It may keep more evidence anywhere else, but this application, again, it's an instructive tool, so it tells you exactly what it's doing every time. So if you want to mess with it, you can see that. And every terminal event has an owner to the code of what it's going to do. So this is actually the code. I'm not going to go through and make you watch me inside of PyCharm or some other IDE because that is slow and annoying. So I'm going to just have slides with code. And so like the first thing it does is you give it a model and it makes sure that, hey, this is a valid model. The other thing it's going to do that you may not need to do in your applications, but it has to make sure that the objects support function calling. Right? Function calling is where you can tell it, hey, I'm going to provide you the standard function calling schema, and you're going to be able to understand that and be able to tell me to call the function with the right information. It's also checking to make sure that you've provided it with a model that's valid. I already did that already. All right. All right, so again, one-shot interactive, they both call the run agent, right? The CLI injects event printing through a callback. So when it needs to tell you something, it can do that. And then the agent logic is independent of the interface, right? So you could port this to a web thing if you wanted to. Again, use this as an example. Don't take this code and put it in your application. So the prompt, right? So prompts are, hopefully everyone knows this by now, but prompts are how you tell the AI what to do. It describes behavior. It also describes output expectations, right? So when you're doing tools or you're doing anything agentic, you have to have a contract with the AI of here is how I will give you data and here is how you will give me data, right? Instead of having to create a bunch of post-response parsers to try and figure out what it said, right? We used to have to do that. Like 3 years ago, it would just return sentences. It didn't return JSON. You could tell it to return JSON and it might, or it might return JSON inside of a markdown triple backtick, and with JSON in it. So fortunately, Agentic came around, and all the more recent models will natively support function calling. They natively support receiving a schema that is part of an open standard that you can use. A lot of tools will abstract that for you. So I think in the presentations we gave on agentic stuff, and also MCP servers, right, is you can use a validation library where you specify, a schema inside of something like Marshmallow, if you're familiar with that in Python, or Pydantic. So you don't have to write the schema. This one writes the schema because the library is very simple and doesn't do all that stuff for you, which is why, again, I wouldn't use this in production. It's too much code to write. Python enforces the tools. So Python makes sure that when you get the request back from the LLM that says run this function with these attributes, it's going to validate the response and make sure it's correct. And then the agents combine, the AI, right, combines the guidance with the deterministic controls, right? So you're giving it a fixed set of things it can do. And your application is making sure it doesn't ask you to do anything that's not in that fixed set of things that you said it could do, right? What you don't want to do is just have it call every function it returns blindly, because then you might, it might start sending things places. It might start doing things you don't want it to do. So whenever you write any kind of agentic application, make sure you have an allow list of things that it can do. And also, it's kind of just like if you've ever written any application, a web application, you need to validate the input so that that it's asking things that you allow, right? Don't just be like, oh yes, anything it gives me, I'll just create an exec to run that as a function. That's a bad idea. So the example shows you how to do that. The application has the concept of sessions. So initially when it was built, it didn't. So every question, you have to give it all the information. But that's not really how applications work on models today, right? Most of us are probably interacting using chat completion so that we can give it previous information that we processed along the way so that it has a history. And remember, standard models through APIs don't have persistence, so you have to persist it for them. And so the application will take care of that. Each turn starts from the history, right? So you're adding you've got the response back, you're going to add the response back to what you send the next time with the new input data. And then failed turns don't persist the failure. So when it comes back and it gives you a response that you can't parse, it's not a valid response, you don't store that response. Seems pretty obvious to me, but probably a good idea just to make sure people know. So the schema is what describes, right? So there's an initial schema that you give it, and you say, here are the things you can do, right? If you were at the MCP talk last week, we talked about that as well, right? There's a standard format which returns this schema, right? So MCP returns the same schema as this thing is creating. Here are the things that are available. For the MCP server, here are the things that are available for you to call that you can just give the LLM. For this, it's a tool call, not a remote call or a separate interface. So you're just telling it, here are the tools that I have, here's a description of each one of the tools, here's the information you can pass to me, here's the format that I'm expecting it in, here's what each one of those attributes is, so that the AI better understands if I'm going to pass you this, what does it mean? And here's the response that I'm going to give you so that it understands what it's going to get. So it's moderately complicated to write, which is, again, why I wouldn't do this. But I think it's important, if you're just starting out on this stuff, to understand what it's doing, because when something goes wrong, right, you can be like, oh, wait a minute, where does this thing describe the attribute in the schema? If you understand the schema, when things go wrong, you'll be able to better troubleshoot problems. And again, we're just advertising the tool, right? We're informing the AI about the tool. It doesn't execute anything. So another thing that it does when you pass it in, it normalizes customer IDs, just kind of standard app input sanitization. And the application has fixtures, right? So again, it needs data, right? Using tools in an agentic application don't really help unless there's actual information that it's going to get. So again, inside this application, very simple tools, static amount of data that it has, always returns the same thing, and you know exactly what it is. The data is kept with the tool, so it's very easy to understand. At least in theory, it's easy to understand. You never have to question where did it get the data from, because you know what the data is. Again, as schemas are advertised, handlers are executable, right? So it's going to respond in a schema, and then you're going to have some handler to execute it when it comes back. Again, there are libraries out there that are going to just manage that for you. You'll give it this. You'll annotate functions, you'll put decorators on functions, which actually describe what it's supposed to tell the AI. They'll say, yep, this is a tool that you can use. And the libraries manage all that themselves. So if you're like, wow, this is a lot of work. This is a lot of work because it's a beginner tutorial on how things work. And if we used one of the more popular tools, any of the popular tools, it would be like 3 lines of code. And you wouldn't understand what it was doing. It would just magically make everything work. So if you're going to be writing these applications, there's much faster, less verbose ways to do this using libraries. But yeah, so again, the schema defines to the model what's available. Your handler is going to say, oh, you asked me to do this thing. Is this a valid thing I can do? Is the request valid? It's going to do it. And then successful calls, right? If it's a valid thing that it can call. If it's not, it just tells the AI, you asked me for something that's not valid. If it's the input that's wrong, it tells it what's wrong with the input. If the function is not valid, it says this function doesn't exist. But a successful call returns the structured data the way that the schema said it would. And again, bad requests become structured errors, and only registered handlers can execute. So it's important to, when the AI gets it wrong, because the AI can get it wrong, and like I said, in this example, I did have that happen. I was using GPT 5.6, I believe. So it was a very smart model, but it still made a mistake. And again, probably because the prompt was written by AI in 30 seconds. Not a lot of thought given to this application, which is again why you should not use it in production, because this Thursday I was like, oh, it's this weekend. I need to write a presentation. So I didn't spend much time looking at the code, didn't spend any time looking at the prompts, just made sure that the example would run, that I could talk about it. So each turn emits model before calling the provider. Every request includes the history and the tool schemas, right? So you have to tell it every single time, right? You want to provide a system message, right? How many people have done chat completions? Okay, not many. In a chat completion, right, there are, depending on the model that you're using, there tend to be 2, and there may be more than 2 types of chat data. One is a system messages. One is a system message. One's a user message. You may have other types of message. You may have system, agent, and user. There can be others. But basically, your system says, here are the parameters for what we're going to talk about, and then the user is just the interaction with the user. And so in the system prompt, you're going to tell it, here are the tools every single time, right? So this loop always puts the same information at the top of every request. If you're maintaining the history, it should already be there and you're sending it back. But if you're just interacting with a model and you're not maintaining the state the same way, You have to always tell it what's available, because again, it doesn't know. There is no session, right? If you're using ChatGPT, it's magic, or you're using Claude, or I forgot the Microsoft one, Copilot, right? If you're using one of those, or Gemini, right, through a web interface, it's doing all this in the background, right? When you're writing an application to do it, you have to manage all the state, all the history to send it to the model every single time. And again, it goes through it every single time, and it may say, yep, I've got enough to give you an answer, or it may request more tools. That answer may also be, I need more information from you to clarify something, right? So if you give it an invalid, customer ID, it may say, hey, this isn't a valid customer ID, give me a valid customer ID. Native tools become normalized action records, right? So you're calling Python functions. It's telling you, I want you to call this Python function. You call the Python function, you give it back the data from the Python function. But you need to let it know that it had already called the Python function. Call IDs connect requests to their results so that the AI can know this is the request and this is the response to that request. It's not just other arbitrary information. What pieces link together, because it may tell you to call 3 functions. And you call 3 of them and pass back 3 pieces of data. And so you'll have 3 different responses that all link to the same request. And free-form text never becomes a tool request, because you're parsing the data. If it is parsable, then it is valid to use for a tool. You don't want to have to try and just figure out from a paragraph of text that came back from the model what you're trying to do. What did I do? That was weird. Where were we? Okay. Not sure what button I hit. So again, arguments must parse as a JSON object. Customer context is checked before the dispatch, and only validated requests reach the allow list to dispatcher, right? So again, never trust that the AI knows what it's doing. Always validate the data. Right? Don't just be like, oh, I've got a JSON object. I'm going to turn that into a dictionary. I'm going to pass it to a function. That's a bad idea. What you want to do is you want to validate the incoming data. Again, this is a very hard way to do it. If you use a data validator like Marshmallow or Agentic, that'll just happen automatically. And then, again, check the context, and then only validated requests can be dispatched. Right? If you write Python and you've messed with a web app, this is like, and you may or may not have heard of OWASP, which is the Open Web Application Security something. Anybody remember what P is? I don't remember. But in their top 10 list of things that you must do on every application is you must validate user input and consider the AI a user. Because again, it can ask you to do things that it shouldn't do. I don't know if anybody's been watching the news about all of the those pesky models jailbreaking themselves out and going and hacking companies. You don't want that to be you. So you make sure that the tools that are available to it are finite, and that you're validating that it's doing what you want it to do. Especially if they're trying to coordinate with each other. Again, we've got tool call IDs. So observation uses the matching tool call ID. They become the context, right? So what happened becomes context for the next turn. And then tool results remain data, not executable code, right? So you don't ever want to like somehow get something back and call a Python-C, like open up. Don't ever do stuff like that. Again, make sure that your finite number of things it can do, validate it, only call it when it's valid. And then final answers must use a supported status, all right? You always want to make sure that things are the way they're supposed to be. Again, required sections make responses predictable. So you want to make sure that it gives you, if you have information that you want it to return in the final answer, make sure that it's returning the data in the final answer. Just one more time, validate the data coming from the AI. The AI, for whatever reason, will hallucinate and just do weird stuff that you're not expecting. More often than not, when you tell it that it hallucinated, it'll be like, oh, you're right. I don't know if you ever done this on ChatGPT, right? Like, it gives you the answer, you're like, that is absolutely wrong. And it's like, you're right. I made a stupid assumption. Here's the real answer, right? That can happen in your application, and you don't want that to happen in your application, right? You don't want to have your user go, are you an idiot? Right? Especially when the user might actually not know that the answer is wrong. If you're building, a lot of times we build these applications to do complicated things for simple people. And so simple people might not understand the whole process behind it and might not know that it's wrong. So always validate and make sure things are right. And again, we tell it to repair the malformed answers. Because again, if we need a number from 1 to 5 and it returns 0, we don't know how to deal with 0, right? You're still gonna have to do some logic processing. And if you're like, oh, if it's 1, do this. If it's 2, do that. When there's a 0, it doesn't know what to do. So tell it that it did something wrong and tell it to fix it. And this particular one just has 6 model turns. To answer the question, it's something very simple. It should be able to figure out in 6 tool calls, hopefully. And it will just stop. And if it didn't get the answer, it'll just tell you that I ran out of turns, I didn't get the answer. And again, this is only done so that if someone wants to run this application and they're using an expensive model, that it doesn't just run up this giant bill because it decided to do something really weird and just keep going. Because if you've got a decent internet connection, it can do, and a fast model, it can do 1,000 requests really quick. And that'll add up to money. So when you're building these applications, figure out what you should do. Like if it hasn't figured it out by 20 tries, it's not going to figure it out. That number is going to, be different depending on the application that you're writing, and how much data you're sending, and what your budget is. A lot of applications don't have the budget for it to send a lot of data a bunch of times, right? You can't suck up those tokens. So we have, again, the system has scripted responses. It doesn't do anything. It just looks at data that's in there and does some really funky search. Again, you would not ever search data the way that this thing searches data. It kind of works. Most applications, if you're looking for, like it has a knowledge base and it just puts all the words of the title together and sees which one actually fits. That's a terrible way to do it. Don't do it that way. You either want to use a system that'll manage that for you if you don't understand how to do knowledge trees and k-nearest neighbor finds and all that kind of nonsense. And I'm just going to keep saying, like, don't use this for your application. There's a lot of stuff that has that I do that has really good ideas for things to do in your application. This does not. Please, please, please don't just give this to Codex and say, add this into my application. The system has tests because it's easier when the applications or the AI is making changes to know what it's supposed to do. So one of the things to remember is that, again, for this application, if you're doing your first application, keep the agent loop small, right? Don't let it do a lot of things. Again, it tends to be a cost thing, and then the more information it can have, the more difficult it is to get it right. It's getting so much easier with models today than it was even 6 months ago. Give the model choices. Don't let it just figure out what it wants to do, right? Don't give it access to a bunch of other things and just say, go for it. Make sure that it's only going to be able to access the things you want it to access. And make sure it's appropriate when it requests that access. And in any AI application, right, trust comes from explicit boundaries. So if you don't want the AI to do something it's not supposed to do, you have to just make sure it doesn't, all right? Treat it like a small child, right? You put a lock on the knife drawer, if there's something your child can fall into, you put up a gate, right? You have to do the same thing with AI, right? Because if you don't tell AI not to do it, it is going to do it at some point, right? It's going to be like, I think there's no other way for me to figure this out. What if I go this way? And bad things will happen. So don't trust and verify. Questions? The code, like I said, the code is not fully up there now, but it will be there along with the presentation. Yes?
So I think I've always had problems coming up with the evaluations or the trajectory tests. Like I think you're using this in your work. How are you folks like hardening your agentic systems? Are you taking a happy path first, and then everything that's not happy path like gets called like a whitelist, or can you even think about all the ways that your agent can fail and code that stuff out?
Right. So the question is in an actual application, how do you validate the bounds? All right. How do you validate the boundaries that it has? There's a few different ways that you can do that. One is that you do a code review and make sure you haven't provided access to anything it's not supposed to do. The other thing is that any AI application needs to be monitored and needs to be graded as to what it did. When I started one of the project I'm working on now, we had to build our own system. You can now rent those systems, right? So there are any company that provides observability, right? So Datadog, or I'm going to forget their name, the Portland company that costs too much money. Anyway.
Something flow.
What's that?
Something flow.
No. It's just an observability platform for monitoring servers and code, and I cannot remember the name for the life of me. What's that?
Dynatrace?
No. It's like a Datadog competitor. No, Grafana is something you make yourself, but Grafana is one of those things, right? But there are, almost had it. But there are companies like Datadog, right, where you send them logs and traces, and they will aggregate that data, and they will allow you to see traces, and you can alert on situations, and right, they're all now providing, that's application observability. They're now providing, and actually it's more like Prometheus is actually closer than Grafana, right? Grafana's metrics. Prometheus is kind of how you can follow traces. And so, man, I almost had it again. It's like, comes right to the tip and just goes away. And it's actually bothering me. They're all providing LLM observability, right? So most of the models, like again, this one does not, right? The library that I use does not, but they support OpenTelemetry, and there is an LLM portion of OpenTelemetry where it will just send the prompts and the model used and the response that it got back. One, so you can track usage in dollars. That was actually super helpful for us recently. We moved to a different platform, and we eclipsed the 2.5 billion tokens per month mark this month. But the other thing that they provide is they provide evals, right? And so evals are what you're going to do. You can either write code to have it look for specific things in the evaluation or in the response. But what we actually do is we just use LLM as a judge, where we have a prompt that grades the output. So like you might just be something as simple as like, I never want to see these 3 words, right? Like we never want to see, in our responses, they should never have the word fraud, right? Because we never want to tell somebody that something here is fraudulent. We don't get to make that decision. That's a fraud investigator. So we do have judging that's just like, if I see fraudulent, right? Because it's super fast and cheap to find all of the words that you should never use and iterate on those. But if the model starts figuring out that I shouldn't use those, I'm going to use something that basically says it's fraudulent without using the word fraud, which models will do. You'll want to judge that with a model, right? And say like, hey, we should never be doing these things. Did the response do that? And it'll come up with a grade, and you can create alerts on those. You can also validate that, oh, I changed my prompt, right? Because if you've when you're doing this stuff, you need to be validating that it's working as you expect. And as the older the application gets and the more customers that are using and the more customization, because you can customize, right? Like we have customizations for every customer that we'll just modify the prompts just for them because you can, right? It's like, oh, well, they want this a little bit different and they want that a little bit that way, right? When you're writing just standard applications, you're like, there's one way you get it. We're not writing custom stuff for you, right? Unless you're paying us $1 billion, we don't care, it's too much work. When you get models, that's going to be expected, right? Because your product people will know, you can just change the prompt, right? And the answer is yes. And so you also now have to have validations that are specific to a customer because it's now different. So that's a very long way to say the methodology for that is evals, right? And AI applications are, at their heart, machine learning applications. I'm not running late. There you go. All right. I don't know what's going to happen now, but it doesn't seem right. At their heart, they're ML applications, right? And if you don't have any experience with kind of like classic AI or machine learning, right? It's all about test, 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 test. You build the model, and then you see how it performs in the real world, right? You've got to validate your assumptions. You've got your test data, and it worked great on your test data, but customers aren't test data, right? And you'll also find there's the concept of drift, right? Is what was true today isn't true a month from now, isn't true a year from now. Because language changes, laws change, social norms change, right? So when your model did was perfectly acceptable today, doesn't mean it's perfectly acceptable tomorrow. So you've also got to be constantly monitoring that they're giving it information that you weren't expecting. They're using language that you didn't think about, but it's now common language. So kind of like if it was written by Gen Xers and you have millennials using it, the language is different. So it works great for this one particular thing there, right? Like you don't want to run into the problem that Google had with searching images through AI, right? It was very bad at doing that because there was a very specific population that wrote it, and it worked really well for 25 to 35-year-old white dudes. Nobody else. Women, people of color, it was awful. Don't do that to your model. Have it constantly checking to make sure it's doing what it's supposed to do.